Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today as we have started the chapter, most important chapter, aldehydes, ketones and carboxylic acid, and in our previous class we have already completed aldehydes and ketones, everything about them like preparation and their chemical reactions, nomenclature, structure. Today's video we are going to start carboxylic acids. Okay, so in carboxylic acid today we will be studying about their nomenclature, which is very important, then structure and some methods of preparation. Okay, so I want all of you to sit with a notebook and a pen so that you can note down all the reactions and you can make flowcharts of the reactions with me. Okay, so now one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. So please go there, join the channel so that you can get all this PDF notes, question paper solutions, everything, mock test papers, everything is available in our WhatsApp channel. So please join the WhatsApp channel. Okay, so now let's get started without any further delay here. So as I told you, how are we going to complete this chapter? So it will be done in 4 parts. So first one, coming to the first part, we have already discussed nomenclature, then we have already discussed structure, and then we have discussed preparation of aldehydes and ketones. Now coming to part 2, here we have discussed physical properties and chemical reactions of aldehydes and ketones. Today we are going to start part 3. That is carboxylic acid, nomenclature, structure and methods of preparation. Okay, and in the next class we will be discussing about physical properties and chemical reactions of carboxylic acid. Okay, I hope this is clear. So now let's get started with the first part, that is weightage wise. So as I told you, you can expect almost 3 to 4 questions from this chapter. Okay, a very high weightage topic. Okay, next one, coming to today's class, that is carboxylic acid, we will discuss nomenclature, structure and preparation. And under preparation we have 6 methods. First is from primary alcohols and aldehydes, second from alkyl benzenes, third we have from nitriles and amides, then we have from Grignard reagent, from acyl halides, and then from esters. Okay, so we will be studying all these methods of preparation today, and we will be drawing this in one flow chart. One single slide will be covering all these reactions. Okay. Okay, so now coming to nomenclature, this is very important. So the name for this carboxylic acid, the nomenclature ends with OIC. Okay, IUPAC name ends with OIC acid, oic acid. Okay, so now as you can see, like first for example, first one, if you see HCOH. Okay, so this is one carbon is there, so that will be your methanoic acid. Methanoic acid, and the common name is formic acid. Now if you have 2 carbons, okay, then we call it ethanoic acid or acetic acid. Now if you have 3 carbons, it is called propanoic acid or propionic acid in the common name. Now 4 carbons, butanoic acid, and here it is butyric acid. Now if you have this one CHCOOH and you have 2 CH3 like this. Okay, so this is your isobutyric acid, and the common name this IUPAC name is 2-methyl propanoic acid. Okay, now coming to these carbons where we have 2 carboxylic acid. This is very important. These common names are very important. The simplest acetic acid with 2 carboxylic acid groups is called as oxalic acid or ethane dioic acid. Next one, if you see, you have 1 CH2 group here, then we call it malonic acid or propane dioic acid. Next, if you have 2 CH2 groups, then we have succinic acid or butane dioic acid. Next, you have 3, then we call it glutaric acid or pentane dioic acid, and next if you have 4, then we call it adipic acid or hexane dioic acid. Okay, so you have to remember this OMSGA. Okay, so here there is no CH2 group, here there is 1 CH2 group, here 2 CH2 group, here 3 CH2 group, and here 4 CH2 group. Okay, OMSGA. Please remember this mnemonic, OMSGA: oxalic acid, malonic acid, succinic acid, glutaric acid and adipic acid. This is very important. Okay, next coming to, if you have like 3 CHCOH group, then we call it tricarbalic acid or carbolic acid, and this called propane 1,2,3 tricarboxylic acid. Okay, the IUPAC name is very easy, but this 4, this 5 OMSGA, oxalic acid, malonic acid, succinic acid, glutaric acid and adipic acid are very, very important. Okay, please remember their structures 0, 1, 2, 3, 4. Okay, fine. Next, coming to the aromatic acids. So if you have benzene ring with COH group, we call it benzene carboxylic acid, or you can call benzoic acid. The common name is also benzoic acid. Next, if you have this one 1, 2, so this is like phenyl acetic acid. Phenyl group is attached, acetic acid, and the IUPAC name is 2-phenyl. On the second position we have phenyl group, so 2-phenyl acetic acid, 2-phenyl ethanoic acid. Next, this is 1,2-dicarboxylic acid, so you have benzene 1,2-dicarboxylic acid, or the common name is again very important here, phthalic acid. Okay, fine. So now let us solve this question. Give the IUPAC name of the following compounds. So first of all, when you do this structure, do this question, try to draw the structure. Okay, so we have pH, CH2, CH2 and then COOH, right? So here you have 1, 2 and 3. So that is 3-phenyl propanoic acid. Okay, first one. Now coming to second one, if you see the structure, we have CH3, CH3, CH double bond, then you have COH, right? So okay, here I did a structure is little wrong. So we have double bond here, then here CH, COOH, right? So 1, 2, 3, 1, 2, 3 and then okay. So now you can just number it 1, 2, 3 and 4. On the third carbon we have methyl group. So I can write 3-methyl, okay, bute. On the second carbon, bute 2-en oic acid. Very simple. Next one, if you see, we have this numbering. So carboxylic acid should get the first priority. So this is second priority. So it is 2-methyl cyclopentane carboxylic acid, right? 2-methyl cyclopentane carboxylic acid. Next, coming to this one, we have 3, 4, 5 and 6, right? So we have 2, 4, 6. So you can write it as 2, 4, 6 trinitro benzoic acid. Okay, these questions are given in your NCERT book, so definitely practice this nomenclature questions. Okay, fine. Now moving towards the structure. So structure, that if you see, this is the structure. You have R, C double bond O and OH, right? So this is a sp2 hybridized carbon. So this molecule is a planar molecule. Okay, planar molecule, and if you see this bond angle 120 degree. Okay, so next is important thing, this carboxylic acid. Okay, so if I see like this R, C double bond O, OH, you can see here it is negative, here it is positive, right? So that means this carbon is electrophilic in nature, right? But one important thing is acids are less electrophilic than carbonyl compounds. Means acids are less electrophilic. Okay, acids are less electrophilic than carbonyl compounds. Okay, so if this is a carbonyl compound, so acids are less electrophilic. Now what is the reason for that? Now you can see that this oxygen, okay, this oxygen gives electron here and this one goes here. This resonance takes place like this. You can see the resonating structure. This oxygen lone pair comes here and this bond shifts here and we get like a partial double bond here, right? So now this electrophilicity of the carbon is reduced due to the presence of lone pairs of electrons in the adjacent oxygen, right? This oxygen is donating electrons, so that means the electrophilicity of this carbon will reduce, right? So that is why acids are less electrophilic as compared to ketones and aldehydes. Okay, so that is, you can see the carboxylic acid is less electrophilic than carbonyl compounds because of the possible resonating structures. Okay, so oxygen being adjacent to this one donates the electrons here, as a result of which the electrophilicity of the carbon is reduced. Okay, Fine. So now coming to the methods of preparation. So as I told you, we have 6 methods of preparation. Okay. So the first one is from primary alcohols and aldehydes. Now coming to the second one is from alkyl benzenes. Third, we have from nitriles and amides. Fourth, from Grignard reagent. Fifth one from acyl halides and anhydrides. Okay, fifth one from acyl halides and anhydrides, and next coming to from esters. Okay, so these all are very easy reactions. Just you have to remember 6 reactions are there. So let us revise once again. First is from primary alcohols and aldehydes. Second is from alkyl benzenes. Third is from your nitriles and amides. Fourth from Grignard reagent. Fifth from acyl halides or anhydrides, and sixth one esters. Once again, let us revise. First one is from aldehydes, primary alcohols and aldehydes. Second from alkyl benzenes. Third is from nitriles and your amides. Fourth one from Grignard reagent. Fifth one from acyl halides and anhydrides, and the next one is from esters. Okay. So now we will start react. So all these reactions I have covered in this one single slide. I want all of you to draw this flowchart and this flowchart diagram. Okay. So the first one is from primary alcohols, right? Number 1 is from primary alcohols. So you just need to remember the reagents. So we have discussed in the alcohols chapter that alcohols on mild oxidation will give you aldehydes, but on strong oxidation can give you carboxylic acids, right? Mild oxidation you can use reagents like PCC, CrO3, copper at 573 Kelvin, but strong oxidizing agents like KMnO4, K2Cr2O7 can convert primary alcohols to carboxylic acid, right? So if you see, this is a primary alcohol with alkaline KMnO4 and H3O plus, we will get this part. Okay, this part gets converted to RCOOH. Okay, next, what is this one? You can also use CrO3 in presence of H2SO4. This is called as Jones reagent. Clear? So we have 2 reagents that we can use, alkaline KMnO4 and H3O plus, or you can use CrO3 H2SO4. This is called as Jones reagent. Now if you use only CrO3, that is a mild oxidizing agent, and that will convert alcohols to aldehydes. Clear? First one. Now the second method of preparation was from alkyl benzenes, right? From alkyl benzenes. Okay. So you have to just take KMnO4, the same KMnO4, KOH, and then you can write alkaline KMnO4, or KOH represents alkaline medium. So KMnO4 itself is okay, then H3O plus. So here what happens, first if you take any alkyl benzene, suppose you have this one, CH2CH3, okay, that one also will give you COOH with the same reagent. Okay, so any alkyl benzene, 2 carbon, 3 carbon, 4 carbon, doesn't matter, the product will be only benzoic acid. Okay, second method clear. Now third method is from nitriles. From nitriles. So first if you treat RCN with H plus or OH minus, it gets converted to amide group, and after that H3O plus will give you acid group. Okay, so you have to remember, first of all, when you treat RCN with H plus or OH minus, it gets converted to amides. This functional group is nothing but amides, right? Now this amides gets converted to acids. You can, so we have this third method was from nitriles or amides. So if you take nitriles, first you convert to amides, then amide should get converted to carboxylic acid. Okay. Now coming to the fourth method was from Grignard reagent, right? So fourth is from Grignard reagent. So if you see Grignard reagent should be treated with carbon dioxide. Okay. Now if you see, this is plus, this is minus. Okay, and here we have this is minus and this is plus, right? So now what will happen? Negative will attack on the positive. So what generally happens, this R minus will attack on this one. Okay, this bond will shift here, and this O will absect this MgX. So you can see R attacks here, O attacks and takes you OMgX. Then if you take H3O plus, what will happen? OMgX will get converted to OH, and we'll again get a carboxylic acid. Okay, so this is your fourth one. Next, fifth one is from acyl chlorides. From acyl chlorides or anhydrides. This is your anhydrides. Okay, so very simple, just if you take first OH minus or H2O, it abstracts this chlorine. Okay, we get RCOO minus, then you can treat it with H3O plus to get RCOH, or very simple, just treat normally with water. This OH will come here, right? This OH is there, it will attack here, this one will come out, and we will get carboxylic acid from acid chlorides. From anhydrides, simple, you have to treat it with water. Then what will happen here, one bond will break. Okay, so the products for this one will be C6H5. Okay, I'll write here, the product for this one will be C6H5. Then we have C double bond O, right? Here one H will come. So if you just imagine what is the, how this water will break, H plus and OH minus, right? So this side if it is breaking, this H plus will come here. So we'll get OH, okay, plus. We have another part, this one, that is CH3, and then I have CO, right? Here this OH will come and we'll get two acids. Please check it, is it clear? So when you are breaking here, right? So if you are breaking here, this is O minus, this is plus, right? So here H plus will come and here OH minus will come, right? We'll get two products like this. Clear? Next, when you break esters, so this is your fifth one, right? Now this is sixth one, from esters. So from esters it is very simple. Wherever this C double bond O group is there, it will break here, okay? And this one it will come H plus and this one will take OH minus. Okay, so we'll get one alcohol and one carboxylic acid. Okay, the products will be one alcohol and one carboxylic acid. Clear? So once again let us revise. The first method is from your primary alcohols. So primary alcohols, you can use any strong oxidizing agents like KMnO4, K2Cr2O7 or CrO3 concentrated H2SO4. The second one is from alkyl benzene. Here also you have to use alkaline KMnO4 and H3O plus heat. Now coming to the third one, that is from your nitriles. So when you treat nitriles with H plus or OH minus and heat, it gets converted to amides. Then you take acidified water, H3O plus, hydrolysis, you will get carboxylic acid, third one. Next, fourth is from Grignard reagent. So if you treat Grignard reagent with carbon dioxide, we will get again this carboxylic acid. Now the fifth one is from your acid chlorides or anhydrides. So for acid chlorides you can simply treat it with water, and from anhydrides also you can simply treat it with water. Now coming to esters, esters again you treat it with acidified water, that is H3O plus. This will give you again alcohols and carboxylic acids. Okay, so 6 methods preparation done. Now let us revise here. From primary alcohols or aldehydes, what reagent we can use? We can use KMnO4, or we can use K2Cr2O7, or you can use CrO3 in presence of H2SO4, that is your Jones reagent. Now from alkyl benzene it is same, KMnO4. Okay, from nitriles and amides we will get H3O plus. Then from Grignard reagent you have to treat it with carbon dioxide. Then for acyl halides and anhydrides, just simply treat it with water. From esters, treat it with acidified water. Okay, so these are the different reagents that you must remember. Okay. Okay, so that's all for this class. We have discussed about the nomenclature, structure and the methods of preparation. Now it's time to practice some questions. Okay, so now let us see this question which was given as a homework. Okay, this is very important question. Okay, very important question. So now the question, if you see C double bond O is reduced to CH2, right? CH2 reduction has happened. Now if you take nickel and hydrogen or NaBH4, this reduces, these two reduces C double bond O to COH, alcohol groups, right? But we have hydrocarbon, so we can eliminate these two options. Now if you see ZnHgHCl and we have NH2, NH2, KOH and ethylene glycol, right? So this is, if you see, Clemmensen reduction, and this one is Wolff-Kishner reduction, right? Now, you know both of them reduces, both Wolff-Kishner and Clemmenschen reduces this one to CH2. Then both can be answered. Is it the correct statement? No. So here is a catch that you need to figure out. Now see, this part is okay. This reactant, what is the nature of this reactant? This reactant, alcohols, right? Alcohols are acidic in nature, right? So if the reactant is acidic in nature, the medium has to be basic in nature. So that is why if you see here, there is already, this is acidic in nature. So that is why this two cannot react. Okay, so we need a basic medium for the reaction to happen. So the correct answer for this question will be option number B. Okay, fine. Now let us move towards the next question. What is the common name of the simplest dicarboxylic acid? So simplest dicarboxylic acid, if you remember, we have just discussed, right? This is your oxalic acid. Correct answer is option number A. Next, what is the correct IUPAC name of the compound given? So if you see, the structure is like this: CH3, you have CH, double bond CH, then another CH, then double bond CH, then COOH, right? So now if we number it, okay, so we have 1, 2, 3, 4, 5 and 6. So we have hexane, so there are 6 carbons, so there will be hexane. So here pentane is there, so we can eliminate these two. Now hexane, at what two positions we have double bond? Second position and fourth position. So hexane 2,4-dienoic acid. So correct answer is option number B. Okay. Now coming to next question, again the correct IUPAC name of this one. So you have C6H5. Okay. Then you have CH2, CH2, and then you have COOH, right? So 1, 2, 3. So 3-phenyl propanoic acid, 3-phenyl propanoic acid. So correct answer for this question will be option number D. Okay, 1, 2, 3. So 3-phenyl and 3 carbons are there, propanoic acid. So correct answer is option number D. Okay, next if you see 1, 2, 3 and 4. Right, why I am giving 1? Because carboxylic acid should be given the first priority according to the nomenclature rules, right? Now when this is a ketone group, right? Now ketone group is a substituent here. So when ketone group acts as a substituent here, the name used is oxo. Okay, so now if you see here, the name parent chain is taken with ketone, so we can eliminate this one. And 4-oxo, this is correct, 4-oxo, 4-oxo, 4-oxo. Okay, now cyclohexane 1-carboxylic acid, here it is cyclohexyl methanoic acid, cyclohexyl ethanoic acid. No, cyclohexane, then on the first position we have carboxylic acid. So correct answer for this question will be option number A. Okay. Next, which of the following has 2 carboxylic groups in its structure? So just now we have discussed oxalic acid, malonic acid, succinic acid, glutaric acid and adipic acid, right? So if you see, the name here is succinic acid 0, 1, 2, 3 and 4, right? So correct answer for this question will be succinic acid. Okay, next, acetonitrile on acidic hydrolysis gives you nitrile. Acetonitrile formula is CH3CN, okay? And if you do hydrolysis, acidic hydrolysis, this part will get converted to carboxylic acid, so we'll get CH3COOH. So correct answer for this question will be option number D. Okay. Next, mixture of acetic acid and propanoic acid is obtained by the oxidation of. So now, if you remember, we have studied in the last class how ketones gets oxidized. Okay, so if you have a ketone like this, for example CH3, CO, CH2 and CH3, right? So there are 2 chances that the bond can break here. So if the bond breaks here, we will get CH3COOH and we can get CH3COOH, right? This is giving you one acid, this one will give you one acid. There is another probability that this bond will break. If this bond breaks here, then I'll get CH3, CH2, then I have this COOH, and this side there is only one carbon, so that will get converted to HCOOH. So total 4 such products we can get. right? So now the question is asking which of these following on breaking ketones will give you two types, both acetic acid and propanoic acid. So definitely aldehydes will not give you such type of compounds, right? So we can remove the aldehydes options. So this one we can eliminate, this one we can eliminate. Now if you see here, okay, so we need propanoic acid. So if I break this bond here, 1, 2, 3, I'll get propanoic acid, and 1, 2, I'll get acetic acid. So that can be correct. Now if you see this one, 1, 2, 3. So if I break here, 1, 2, 3 and 1, 2, 3. So both sides will get propanoic acid. And if you break here, then we'll get 1, 2 butanoic acid and acetic acid. So correct answer for this question will be option number B. Okay. Next, so here is a question now. So CH3 hold to CO is there. So you have CH3 groups here. Okay. Then CO group, and then you have NaCN and HCl. Right. So what will happen? Cyanohydrine will be attacking. So we will get here CH3, COH, CN, and then again CH3. Right. Now if you see H3O plus is there, what will H3O plus do? Will convert CN to COH. So I have CH3, CH3, and then we have OH, and then we have COOH. Right. So the correct answer here will be, first one will be CH3 hold to OHCN. Right. This part is correct. This is also correct. This is also correct, and this is also correct. So all the first one is correct. Now here we will get CH3 hold to CHCOH. So correct answer for this question will be option number A. Okay. Next question, again we have a similar question here. Product B is, so you have CH3COH. Okay. If you treat it with HCN, what I'll get? CH3COH, H and CN. Next, if you see H3O plus, so we will get CH3, COH, H, and then COOH, right? So what we'll call this one? If you see, this structure is called as your lactic acid. Okay. So correct answer for this question will be option number C. Now you may ask, like, how will you know the structure of lactic acid and all? So when we study the biomolecules chapter, okay, in there the such organic acids which are used in the body, those structures are there, right? So from there you will be remembering the structure of these acids also. Okay, next. Consider the following sequence of reactions and identify the final product. Okay, so first you see CH3, CH2, MgBr with magnesium and dry ether. So this one will give you Grignard reagent, right? The first one will be Grignard reagent. So I'll get CH3, CH2, CH2, MgBr, right? So this is your X. Now it is treated with carbon dioxide. Now if you see carbon dioxide reaction, just now I taught you how to do. This is plus, this is minus, and this is minus, and sorry, this is plus and this is minus. So what will happen? This will attack on this one, this bond will come here. So I will get, now we have C double bond O and we have O MgBr, okay, and then this one is connected to CH2, CH2 and CH3. Right. Now this OMgBr gets converted to OH. So we will get OH. So we'll get 1, 2, 3, 4 butanoic acid. So here you see 1, 2, 3. This cannot be answer. Here this is not a straight chain, not the answer. 1, 2, 3, 4, 5, not the answer. 1, 2, 3, 4. Yes. So correct answer for this question will be option number D. Okay. So okay. Now this is a homework question that you have to practice, and like you have to solve this question, and do not forget to comment down the answers. Okay, so I hope today's lecture was very easy. Okay, 6 methods of preparation. So let us revise quickly once. So the first one is from your primary alcohols and aldehydes. Second one is from alkyl benzenes. Third one is your nitriles and amides. Fourth one, Grignard reagent. Fifth one, acyl chlorides and anhydrides, and the last one, the sixth one, is from your esters. Okay, so quick, very small reagents are also water. Acidified water is most of the time reagents used. So very simple reactions. Please make a flow chart of this and remember all these reactions. Okay, so students, that's all for this class, and in the next class we are going to discuss very important topic, the acidic nature of carboxylic acids, and we'll be talking about the chemical reactions of carboxylic acid, and we'll be practicing a lot of previous year questions. Okay, so please, if you are liking these videos, if this is helping you in your KCET preparation, do not forget to subscribe the channel and do not forget to join our WhatsApp channel. Thank you for watching, and see you soon in the next episode where we are going to discuss carboxylic acid chemical reactions. All the very best for your KCET 2025 preparation. Please do not forget the target, that is 60 out of 60 score we need to make it. So please work hard, study smart, and work hard every day to achieve your goal.